So we started 7-1 yesterday. We got 3 examples in. We started a 4th example, and then we got caught up by the bell. So we're going to go back to that 4th example. Just a refresher. What we're doing right now is all revolving around substitution. You're substituting formulas, which we call identities. We don't use the word formulas, we say identities. You're substituting identities left and right, trying to clean it up, trying to simplify, trying to cancel things, trying to condense it. And the whole concept is what you started with, if you were to graph it, should be the same thing you end up with if you were to graph it, but they look totally different. This is one of the toughest lessons because a lot of people are not comfortable with the concept of substituting. It's like a free choice. You have to look at it as a puzzle. If you think of it as a puzzle that's not linear, there's, you go this way, you go that way, but the end result is the same, then it does make it easier. The other thing that makes it easier is looking at these formulas, and I'm going to keep adding to them as we go, but looking at them over and over and just get comfortable with them. You're not having to memorize it. It's just when you look at something, you should be like, why does that look so familiar? And then you go to your formula sheet and your eyes find it, and that's when you're like, oh yeah, because it's this, and then you can substitute. That's what makes this easier, is just continuing to look at the different formulas and thinking about manipulating them like a cup game, which is right where we're fixing to go here in just a second. This first one right here, sine squared, can also be written as 1 minus cosine squared. That came from sine squared plus cosine squared equals 1. That was, just a reshuffling of it. And that's what I'm fixing to use for the problem that we didn't finish yesterday. You just got to get comfortable with, like, what if I move this over there? What if I move that over there? What would it look like? Would that help me? And that's the approach here. All right, so we were on B. The hard part was the top. You've never seen a trig expression reduced to a quadratic expression. Now you have. Oops, here. This quadratic expression, you should be comfortable factoring. The new part is just recognizing when you can take the trig expression and rewrite it as a quadratic, and then factor it nicely, and in my opinion, easier, and then put it back in as a trig expression. Yes, sine stands for y. I just chose to put it as x because the majority of the time when we factored quadratics, we were factoring with x back in college algebra. If this bothers you that this said sine instead of cosine, you could have written 2y squared plus y minus 3 and still factored it like normal.
So is that how we're going to approach it every time?
That's the way, yeah, that's the way that I approach it because I can see that faster. I block out, like I kind of think to myself, like this is 2 something squared plus something minus 3. And then I just replace it with what I'm accustomed to, x. And then I manipulate it. Then I go back and wherever there was an x, I put a sign. In this case, sine of t. That's the recommendation that I would make. That you don't have to go that way. You could have factored it straight with the sign expressions. What I have found that sometimes people struggle with is the t. The sign of t in there throws them off when they're factoring it. The t, sometimes they think of it as a variable instead of it's like a block sign of t. So I have seen people mess up with that. But it's up to you to decide how you want to approach that. So the top part we have now in factored form using the trig expression. Now let's look at the bottom part. 1 minus cosine squared minus sine squared. Minus sine. So the first thing you should notice is that one of those is squared and the other one is not. You've got cosine squared here, and then you have plain old sine. So that means that like these two you can't couple those two together and replace them with anything because one's squared and one's not. You do have a 1 in there. Anytime there is a 1, go back to this one. Oh, that was a white highlighter. Hold on. Go back to this one and think to yourself, is there a cup game here? Is there a shuffling that would help me reduce this down or write something smaller? So back over here, we have 1 minus cosine squared, then minus sine. So if you look at this and group it in your mind, like, okay, so 1 minus cosine squared, that's an expression. Going back over here, 1 minus cosine squared is the same thing as just sine squared. You see that? So I'm going to substitute. Going back over. All right, so I'm grouping this, and I'm saying to myself that 1 minus cosine squared is actually sine squared. I'll change colors so you know where it comes from. That's actually sine squared, and then I'm going to copy what's left. Minus sine of t. When you're doing this, if you have a fraction, use pieces that you've already simplified as clues and indicators of directions to go. Right now, this looks like a hot mess. On top, I've got 2 sine plus 3. Over here, I have sine minus 1. Then I have sine squared minus sine. This should be your clue. Look at that compared to this. So you've got on top sine minus 1. On bottom, you've got sine squared minus sine. What could I manipulate on the bottom to make it match the top? There you go. Notice this has 2 signs here and then just the 1 here. What if I pulled a sign to the front by division? What would I be left with? I'd be left with a sine minus 1, which would then match, which would cancel. And all that mess would be gone. So that's the game plan. Okay, so right here, I'm just going to rewrite the top. 2 sine t. This is that stuff. Remember me saying one day we're going to have problems that take up an entire page? Yeah, that's coming. Not a lot of them. We'll have like 2, but they're going to take up an entire page. On the bottom, I'm going to pull sine of t to the front by division. I'm factoring it to the front. I would be left with a sine of t minus 1. Remember the rules of canceling. Think back to Algebra 2. You can only cancel common factors when they are surrounded by multiplication. So like right here, this sine of t minus 1 and this sine of t minus 1 is attached right here by multiplication, right here by multiplication. So this could factor out like its own fraction, which would cancel and just be a 1. Okay? Had there been, hypothetical, had there been like a plus or minus sign right there in between those, you can't do this. Because then it's linked, it's attached to it. Like that's an even bigger term, an expression, okay? So be careful when you're canceling things. Make sure you can actually cancel. So this is gone and gone. And now if you look at it, you've got 2 sine plus 3 over sine. Here's where you're going to have to look at it and say, okay, that's not enough. That did clean up a lot. There's less here. But your mind should be saying to yourself, I see a sine and a sine right there. I need to somehow manipulate this without breaking any math rules. I need to manipulate this because if I can get just a sine over sine, that would cancel as well, right? Do you see that? Now you can't just run in here and cancel it. You can't slash it out yet because the top is attached to the 3 by addition. That's what I was just talking about up here. That's linked. Terms are separated by plus and minus signs, and the only things that can cancel are fully matching terms. But you can look at it and say, okay, can I tweak this somehow to get that as a fraction by itself? Because if I can, then bam, I can cancel that out. And the answer is yes, we can tweak it. It's going to be uncomfortable. This is probably everyone's least favorite way of simplifying. That's one big fraction, right? Why don't we separate it into 2 fractions? Because if we separate it into 2 fractions, then the first one would be the sine over sine, which would cancel. The second one would be 3 over sine. And what is it? What's the reciprocal function when sine's in the bottom? Cosecant. So then I could write it as cosecant instead of 3 over sine. So I'm going to, you got 2 steps left. I'm going to draw an arrow and say I'm coming over here. Related to just plain old numbers, you don't have to write this, but for example, if I had 2y plus 3 over y, right? That means that came from something over y added to something over y. Do you agree? So the idea is we need to split that up, and you split it up in the top by separating from the plus and the minus signs. So this would be 2y over y, and then 3 over y. So over here, I'm going to say to myself, okay, I'm going to separate this with sine of t on bottom. I want 2 fractions. Then you look at the top, and you just separate the terms. So you got 2 sine of t, and then you have 3. And bam, right there's what I wanted. Notice right here I have 2 sine t over sine t. What happens with the sine t? Cancels. Right here. Gone, gone. So that's just 2. Three over sine t is the same thing as 3 times 1 over sine t. What is 1 over sine? Cosecant, right? Go back to that first slide. Right here. Right there. 1 over sine is cosecant. Well, that's the same thing as 3 over sine would be 3 cosecant. Same thing. Y'all see where that's coming from? So this is 3 cosecant of t. Now look at where we started. This hot mess right here. Look at where we ended. This right here. Understand that we cleaned it up. We used substitution. We canceled out when we could. And now we wrote it as a clear, concise expression. If you were to graph both of those, they would match. Yes?
I can put in this how you got sine t out of the 1 minus cosine squared.
Oh, okay. Right here, I noticed that 1 minus cosine squared is the cup gain from this right there.
Oh.
And replaced it with sine squared.
I'll never be able to see that.
You will. Just practice as we do the practice problems in the notes, and as you do the homework, you'll see it. It comes up a few times. Anytime you have 1 in the back of your mind, if you see the number 1, think to yourself the sine squared plus cosine squared, and then if you see a minus, then write sine squared plus cosine squared equals 1 and shuffle it. And so then you kind of have a leeway of, okay, maybe I can get here, because if I can, then I can substitute sine squared. This is also why the test is not going to be on My Math Lab, because you may see it in a different direction. And you can still get to this. Oh, that's a check mark. Anyways, you may see it in a totally different direction, and you can still get here. So that's why I don't agree with the My Math Lab, and I've told GNTC, they're like, why is your Chapter 7 test not showing up on My Math Lab? And I'm like, because I did it by hand. We did it on paper. Because if you know trig identities, you know there's not one linear way to get to the answer. And it's not fair to penalize a kid for not seeing your way, the computer's way, when they might see the other way and still get to the answer. All right. The only way you're going to get comfortable with this is if we just keep practicing. I know y'all hate this. I promise if you'll give it a chance, you may actually end up liking it. Yeah, it's only day 2. We've only had 4 examples, so don't make your mind up yet. All right, look at this one. It says to add them, then simplify it. So you've got cosine over 1 plus sine, then you've got tan. I have like 3 routes written on my paper. This is one of those where a kid said, I see it this way. And another kid goes, I see it this way. And then I saw it one way. I'm trying to think of which one y'all want to see. So it says to add, you need to go back to college algebra, and this is chapter R. This is a little bit of chapter R. If you go back to like x over 1 plus sine, I'm just writing this, plus, let's see, tangents y over x. So go back to college algebra. When we were adding and subtracting rational expressions, you had to get a common denominator to be able to condense it, right? The good news is we don't really have to do that here because it's trig expressions. That would be insane. You do, however, have to understand that if I'm going to add or subtract to one fraction, then I do have to account for the denominator. So like the first fraction already has a denominator. It's 1 plus sine. The second part, as of right now, is not a fraction. It's just tan. One direction, and this is the direction that my mind saw, was, okay, well that's tan, which is understood to be over 1, so it's missing a 1 plus sine in the denominator. My mind saw that this is over 1, and if I want to be able to write this as one big fraction, then this tangent would need 1 plus sine over 1 plus sine multiplied by it, because then I would be able to write one big fraction, and then I can start cleaning stuff up. That's the way that I saw it. I'll show you an alternative way after I finish my way. Okay, so I said to myself right here, this tangent, I'm going to write it nicer, I already wrote it once, is understood to be over 1. I need it to be over 1 plus sine. So to do that, I would multiply it by 1 plus sine over 1 plus sine. Right? You can multiply by anything as long as the top matches the bottom, because now you're just multiplying by a really fancy 1. It's ugly, but it's just 1. So I'm not changing the value of anything. Then I said to myself, okay, I know now I can write one big fraction, right? I've got cosine plus tan times 1 plus sine, and it's all over 1 plus sine. Yes? 2 ways to write this. You decide which one you like. You don't have to write both. The one way to write it is exactly what you see, which is cosine x plus tan times 1 plus sine x all over that common denominator. That's one way to write it. I personally said to myself, okay, that's a lot. I'm just going to write this. That's the top, right? Everybody with me? And then I'm going to say to myself, here's the denominator. I'm just going to pull the denominator out, like it's out here. Then I know, okay, I've got all this mess on top, and it's all over 1 plus sine x, but I don't want to deal with 1 plus sine x right now, so I'm pulling it to the front. You don't have to do this. Your mind may not see it this way. If this is a stretch for you, then don't go this way. Go the way that your mind would naturally think. If you see this, if you understand it and you like it, then consider it as a technique for not having to write a giant fraction every time. This is saying, hey, don't forget that is all over 1 plus sine x, but I don't want to deal with that yet, so I'm going to show it to the very, 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 very front. That's one way to do it, okay? All right, and then now, if you look at what we have cosine plus tan times 1 plus sine x. What do you think we need to do with the tan and the times 1 plus sine x? This right here. What do we need to do? Okay, are you trying to cancel that? You can't cancel that because this tan right here, even though that is attached by multiplication, that tan in front of it is attached by a plus sign. So this is being multiplied with the tan, so we can't cancel that out. Let's multiply the top and let's clean it up. So I'm going to take tan and multiply it with those two things. So across the top I've got cosine x plus tan x plus tan x sine x. Now that's the top, right? That was just the top. If you want, you can write this all over 1 plus sine x, so you're staying consistent. Or you could say to yourself, I'm just going to work with the top real quick. You're making a note like, okay, I'm just going to manipulate the top. I need to clean the top up before I put it right back into that fraction. So I'm not going to write, because the bottom can't do anything for me right now until I clean the top up. The top is a mess. Y'all ever seen the campaign? No? I can't. Zach Galifianakis? I think is how you say his name. Okay, anyway, never mind. You'd have to see it to know what the joke I'm getting. So this is the top. Now I'm going to clean this up. When I say clean this up, right here, tan times sine, and then this tan right here, those are fractions, right? So let's write what the fractions are, and let's try to get this to just one expression, or as small of an expression as possible. So cosine is just plain old cosine. What's tan, y'all? Sine over cosine. This is sine over cosine times sine, right? Over 1. Okay, looking at this, you have cosine plus fraction multiplied by sine. If I wanted to be able to write this all over one common denominator, what would the common denominator be? Remember, terms are separated by plus and minus signs. So you've got 3 expressions. I want to be able to write it over one, like as one fraction. So what would the denominator be? It'd be cosine, right? If you look right here, like that already has cosine, that has cosine, this one here is not going to change it. This is an understood what? This is an understood 1. So what do I need to multiply this by in order to be able to write it as a single fraction? This needs what in the denominator? This needs a cosine. Now here's where you might be getting lost in this, and this is where there's a technique where you say to yourself, okay, I'm going to multiply this by cosine over cosine. You don't write the whole thing out because you're just saying to yourself, okay, I'm going to multiply that by a fancy 1. And then this would become what? Cosine squared. So watch. This would become cosine squared. This is still here. This is what? Sine squared. And the idea was it was all over cosine, right? Now I can write the whole thing over cosine, and that's because of the blue right here. Because I said to myself, I can't do this all over cosine unless I multiply that first part times cosine over cosine. This is a really tough problem, so please don't quit on me. I'm not. I'm manipulating it.
Literally, like, you look at it and you're like, that's not good.
I don't get how, on the first one, I see how that would be cosine, but then why is sine over cosine not cosine squared?
Because I only multiplied this by cosine over cosine, which is because that's a 1. So remember, the rule of like multiplying on both sides of the equation, whatever you do, we don't have an equation here. It's not an equation. So the only flexibility you have is multiplying by 1, because you're not changing anything. You're changing the appearance of it, but in terms of typing it in the calculator and getting the ugly decimals, you're not changing the value of it. So you have the freedom of multiplying by 1 wherever you need to tweak the 1. So my 1 is cosine over cosine. And I can do that because since that's just a 1, I don't have, there's nothing to balance, like, because I didn't put it off balance. So I left that alone, because that's already got the denominator that I needed, and that one did too. that one needed it. Now, what do you see?
1.
Yeah. You see cosine squared and a sine squared with a positive? Let me highlight it. You see right here, cosine squared plus sine squared. That's 1. So this is where highlighting is helpful, because technically you would like regroup that and then call it 1. We're running out of room. So I'm going to highlight it to say, hey, direct your attention right here, directly in front of you. That's 1. Copy what's left over cosine x.
It's literally the exact same.
Well, okay.
So we made all of
No.
that.
Hold on. Now here's where we've run out of room, and this is where, like me saying, hey, you could have also written it over here like that. I'm going to have to erase it because I have no room. This, remember, was just the, I know, that's the face, I know. Oh, it's going to be so much fun. Imagine being a teacher and having to teach it now when the kids are like wanting to throw something at you. Yeah. All right, it's gonna be great. It's just, you know, there we go. That was just the top. The bottom. That was. Let me color coordinate here. This. Oh, color coordinate. I changed colors. This was just the top, which is now this. You probably can see where this is going, but now I've got to put it back in the top. Okay. I'm going to erase this because I have no room. And I'm going to come over here, and now I'm going to make a note to myself, okay, I've got the full thing now. The full thing is this mess that I just simplified to, and here's where drawing really dramatic fraction bars is helpful. That is in the top of a big fraction, right? Well, it's already a fraction, so don't get confused here. Say to yourself, okay, that's in the top. I need a really big fraction bar. And what was in the bottom? 1 plus sine x. Don't complicate it. It's the foundational principle you learned in middle school. You can't divide fractions. You keep, change, flip. All right, so that's why the dramatic fraction bar is helpful, because this is going to keep, this is going to change, and this is going to flip. When you say flip, you mean it's now going to be 1 over that mess. So let's keep, change, flip it. And then now you should be like, hey, look at that. That entire factor right there matches that entire part. And I can cancel them. You're going to love this. So you end up with 1 over cosine. What is 1 over cosine, y'all? Secant. Okay. Let me say this. That's probably one of the hardest problems because of the common denominator. You had a lot of fractions within fractions. You had a little substitution right here. Then, oh no, you had to tweak this here with the cosine. Then you had the substitution. Then you had to remember keep, change, flip. This is probably one. I would rate this like level 3, level 4, or 1 to 5. 1 to 5, not 10. I'm 20. What are you talking about? I would rate that like level 3, level 4. And this is where I tend to lose people. I have a note right here. Stay with it. I tend to lose people right here. So, please don't shut down on me.
It literally does not make any sense at all.
none of that makes any sense. Like, none. I
Don't put a wall up. It's okay if you don't understand it. But try not to talk yourself into a corner where you're never going to have a chance to understand it. And just
we
remember,
just added like random things everywhere. Like, where did you even get it? I don't even know how to even understand it because I don't even know where you got it.
that's just the flexibility of math that I can do. Yeah.
So this is a level 3 or 4. What is our chapter?
Oh, a mix, like, level 1.
All level 5. Prestige 5.
All right, y'all, I'm starting to sweat. I'm carrying the weight of y'all's stress. Don't get stressed out about something that's not this week or next week. This is you're looking at like 3 weeks, Yes. We're going to be practicing. It builds on itself.
It goes.
Wait, okay, maybe that wasn't the right thing to say. Yeah.
In the very beginning, why did you put the 1 plus?
So in the very beginning, I'll show you. So in the very, very beginning, my thought process was, okay, that big old fraction is going to make me get confused. So I pulled it to the very front. Oh, because I wanted to be able to write this as one fraction. And this denominator here needs to be the denominator. Yeah. Yes, yes. Josh, did you have a question? Yeah.
How do you get 1 from cosine squared and sine squared?
Oh, right here.
Right
Right there.
there.
Anytime that's in an expression, as long as they're both positive.
You just put mine
So, great question yesterday. Someone was doing the homework and texted me and was like, hey, can I think it was sine squared minus cosine squared. And they said, can I write that as -1? Because your mind would think, oh, if it's plus, it's 1. But if it's this, it can be -1. And the answer is no. It has to be positive sine squared, positive cosine squared is 1. Or they both have to be negative, and then you would divide a negative out, right? And they would be positive, and then you could write it as -1. So it's an all or nothing. They both are positive, or they're both negative. But you can't do one positive, one negative. It won't work that way. So make sure, because that does come up where I think in one example where you want to force it to be 1, but one of them has a negative sign and the other doesn't, and it won't work. So just keep that in the back of your mind. All right. Okay. Go to this example, 5 and 6. 5 and 6. We are going to get what we got two of these, and then we're going to get to some just. I know. These actually, in my opinion, these are the easiest ones, and for some reason people miss it, and it's because I think they complicate it when it's really not. It's just got a radical over it. It's just the same thing. All right, so we've got multiply and simplify. You've got the square root of sine cubed x, cosine x, times the square root of cosine x. The same rules of radicals apply here. You can multiply any two radicals together. They don't have to match. So this can just shove together. All right, so we've got the square root. Sine cubed is still there because there's no like term over here in terms of like being able to condense it. But then you have cosine x times cosine x. I can write that condensed as cosine squared. Oh, I started to write an S. Cosine squared x, right? Cosine times cosine.
Well, what about the sign?
Well, I haven't done anything with it yet. I just wanted you to see that, okay, Cosine times cosine is cosine squared, right?
But does it have to be
I'm not done.
the cosine is a sine? Since it's
She's saying,
Let's just shove it.
she's saying like you have to like factor like would it be sine, cube, cosine, I guess that's one thing.
It's just one term.
and
Look,
it's
look, look, look. Go to X and Y's. Go to X and
still
Y's.
doesn't even matter.
Yeah, look right here. Look, go to X and Y's.
I don't get it.
Yeah, you just.
I
No. Look, go to X and Y's. That's y cubed X times X, right? Y'all see what I did there?
Only multiply the x's if the y and x are under the same thing, and you put that together with
Look,
affects
it's
the
still
y.
multiplied.
Oh, good Lord Almighty.
But you don't change it. Like, look right here. Look right here.
I don't want to know anymore.
Y cubed X times X would be y cubed X squared. Y'all with me?
Yeah.
Okay. I'm trying to think what grade level. 8th grade? 9th grade? You learned simplifying radicals. Okay, so you learned that like the square root of 4 is 2. Square root of 9 is 3. The square root of x squared is x. Recall that I'm gonna come over here and I'm gonna say recall. The square root of x squared is the same thing as saying that's x times x. Well, there's 2 of them, so the square root of x squared is x. Because you're saying to yourself, what times itself gives me x squared? X. X times x is x squared, right? The shortcut that you learned in 9th grade was instead of writing it out in expanded form and then coupling the pairs, that's the way that some teachers teach it. I don't teach it that way. That's the visual. The shortcut is you just say to yourself, the exponent divided by 2. Because you're cutting, like, when you're taking the square root of x squared, you're just saying, what times itself would give me x squared? And the answer is x to the first power. Now, right here you got y cubed, right? Okay, so you have to think to yourself, y cubed, 2 ways to do this. Y cubed is y squared times y. Everybody agree? I pulled a 2 out because it's to the 3rd power. So I pulled a 2 out because what is the square root of y squared? Y. And that's an odd number. I can't do anything with it, so it stays under the radical. Okay? You already learned this. Now, you may be freaking out on me. You already saw this. You just not practiced it since the last math class where you used this. There is another technique. Let me show you. Alright, so the technique that I tell my students, once I show them the visual, I say, the way to do this is you go into the variable and you just divide the exponent by 2. So, go to your calculator, or you can do this in your head. What's 3 divided by 2? You with me? It's 1.5, right? So the 1 right there means that a y comes out to the first power. The half means there's 1 left. It means there's 1 left behind. Okay? And then what's the square root of x squared? X. I don't want to lose you on something that you already did in a previous math class. So please trust me that you learned this at some point. You just haven't practiced it in a while. So let's just drill it out for a few times. The square root of x to the 4th. It's x squared. Drill it out, y'all. Repetition, okay? The square root of x to the 5th. Odd, it's an odd number. Visualize to yourself, the closest even number would be 4. So that would be x squared, comes out nicely, but it's an odd one, which means 1's left under the radical. Every time. Because every odd number is only 1 away from an even number.
What's like the actual problems? Are we gonna have radicals greater than like square root? Like, are there gonna be cube roots or?
Oh, no, square. And there's only one of these on the test. All right, let's keep drilling it out. X to the 6. Participate with this. I promise it's going to help. That would be what? X cubed. It's the same steps over and over. Let's keep going. I'm running out of numbers. Let's see. X to the 9th. Take a second. Don't say it out loud yet. Hold on. Okay, the thought process is that's odd, which means you can go ahead and say to yourself, there's 1 left behind. Go to the closest even. It would be 8 divided by 2. Comes out. And then that's even, so comes out. You see it? Is it feeling better? Yep. Wait a minute, you lost it. Oh, I put it. Alright, first let me say this. Don't let the X right here throw you off. That's the angle. You don't even have to read the angle out loud. What you need to focus on is the trig part. So you got cosine squared, some angle. Sine fifth, some angle. Okay? Even. So divided by 2, what would come out? Cosine, angle. Odd. That means 1's getting left, right? One of them's getting left behind. Go to the closest even. It's a 4 divided by 2. Sine squared. Same thing. Okay? So now, go back to the example right here. We did this. Now this was us. So now this probably looks a little easier. Maybe. Here's what we got when we multiplied it. We condensed it. And then this was ugly, so we said, let's just deal with variables instead of trig functions. So I said, that's actually y cubed, and that's cosine squared. So that became this, right? And then now, what we were just drilling out. Okay, so that's odd. So 1's left behind. Go to the closest even, it's a 2. Divided by 2, it comes out as y to the first. And that's even, divided by 2, it comes out as x to the first. Then go back and replace. Y was sine, x was cosine. Okay? So this is your answer, but you need to write it in trig format of the angle x. So you got sine x, cosine x, square root sine x. Now, let me say this. This particular problem, and there is one of these on the test, this particular problem is one of those where I feel like what you started with really doesn't get any more condensed than where you end. So I think it bothers people that they're in this mindset of I should be shrinking the expression. And with radicals, it doesn't really shrink, and that's because some of it comes out. But there is one of these on the test, and it is that same level of difficulty. It's not a cube root, it's not a 4 cubed. It's that level of difficulty right there. Remember, I made this test, not my math lab. All right. One more problem. we're going to call it a day, and we're going to go to the My Math Lab homework and start making sure you're okay with the first couple of questions. I could keep going, but I'll just push that to tomorrow. Okay, rationalize the denominator. All right, let's do another related. You can write this somewhere if you want. There's probably not a lot of room, but anyways, let's say you had 2 over 3, and it was that. And I said to you, you need to rationalize the denominator here. Well, one way to write this is separate radicals. And what's the rule in math? You can't have what in the bottom? You can't have a radical in the bottom. You should already know how to approach this. Rationalizing means you're going to multiply by whatever the problem is. The problem is the square root of 3. We're going to multiply by square root 3 over square root 3 because that's just a fancy 1. Then you just multiply straight across. Now those are both under radicals, so you can multiply that. And then this becomes the square root of 9, which is 3. And then that is what's called a rationalized and simplified form. Okay, we're going to do the exact same thing, but with a trig function. Doesn't change the rules of rationalizing. Instead of multiplying by the square root of a number, we're going to multiply by the square root of a trig function. So when we go back to the notes, we have the square root of 2 over tan. Okay, so I'm going to come over here and I'm going to rewrite that as the square root of 2 over the square root of tan. Notice you're going to find that I don't say the angle because I don't want x to throw me off. I just say the trig word. You do have to write the angle, but I don't say it in my head because there's already a lot going on here. Okay, so to rationalize this, I'm going to multiply by what? What's the problem? Square root of 10 is the problem. There is one of these on the test, just one. And it drives me nuts when people get it wrong because this should be one of your easy questions. Because there's no substitution, there's no, like, ooh, I'll tweak it, like you said, now I'll tweak it this way, or I'll tweak it that way. Like, there's none of that. This is just straight up, same thing here with the multiply and simplify. This should be banked as an easy question because there's no free choice involved. It's just the basic rules of breaking down a radical. Okay, so now you're going to multiply straight across. Those are both under a radical, so they just shove together under a radical. You got 2 10x. Don't overthink this. Square root 10 times square root 10 will be square root 10 squared. Back to what we were just doing, simplifying. That's even, so divide it by 2 and it would just be 10. And that's the answer. Do not look at this and say to yourself, oh, there's a 10, there's a 10, I can do that, and then the answer is square root 2. Can't do that. The 10 in the top is under a radical, the 10 in the bottom is not. They are not like terms, I guess you could say. So don't get too excited and just start canceling stuff. So that's the answer. Tomorrow, we will pick up with sum and difference identities, which is going to involve your unit circle. So, now what I want you to do, because I am definitely saying we're starting 20 minutes early. I want you to go to your My Math Lab, and we're going to just start looking at the homework problems that you can do so far, okay? Here, you can use my, yeah, you can use my backup. Okay, so 17 questions. I'm looking at mine that are worked out. Let's see. 1 through 10 is how far you should be able to get so far. Okay, 1 through 10. Number 11 picks up on, let me confirm. Number 11 picks up, yeah, that's the stuff that we're going to do tomorrow. So it's 1 through 10 that you should have and be able to finish. Now, like number 10 right here. Number 10, I would say, is a higher degree of difficulty than the one that's going to be on the exam. There's no way for me to change. It is the only question in this homework that involves rationalizing. So that's why I'm leaving it there, because you need a rationalizing problem. But the one on the exam is going to match what was in the notes in terms of degree of difficulty. So let's look at number 10, since it's a more challenging one. All right, so we've got sine squared over 17 cosine squared, and it's all under a radical, and the directions say rationalize the radical. So the first thing, you walked out. I'm not mad at you. It's just my luck. You walked out, and the door was open, and then you just jumped some more lines. You're fine. You're just on my list. It's okay. So when you first look at it, I know your first thought is probably, why did I got to throw the 17 in there? I'll agree. I don't know why the 17's in there. It kind of throws it all off. All right, so let's look at it. I'm going to rewrite it. I call this a la carte, meaning I'm writing it separately so that I can compartmentalize in my head what's going on. I can clean up the nice stuff that we'll clean up, and then the stuff that's ugly will still be under a radical. So on the top, you have the square root of something squared. Don't overthink this. This is just the square root of something squared, so this becomes, on top, what? Divide the exponent by 2. That means it comes out as, what's the square root of sine squared? Just sine, right? So on the top, I would have just sine of the angle that they gave me. Now, can you take the square root of 17? No. Can you take the square root of cosine squared? Can you take the square root of cosine squared? Yes. What would it be? Okay, so I'm going to pull it to the front. But we just agreed that you can't take the square root of 17, so that stays there. So now you can see that I'm only rationalizing the 17. The 17 is the problem. You're not actually multiplying here with a trig function. So what do I multiply by or with? The square root of 17 over square root of 17, right? Now, the computer does want you to clean up the sine y over cosine y. Our practice example didn't go that route. I'm pretty confident the test doesn't go that route. I think I just left it as already as tan. I didn't throw sine over cosine at you and hope you get to tan. I just left it as tan. So right here, this, there's no back arrow. I just accidentally covered my y up. But this is actually just tangent, correct? And that would be in the top. So this right here is actually tan of y over the square root of 17 is another way to write it. You see how I got that? and then the square root of 17 times the square root of 17. Now you can see why the answer is what it is. So this would be tan square root of 17 all over 17. Now, their formatting is this. I think they take either way. I'd be curious to know. Actually, let me try typing it in, and let me confirm if it'll take it that way. It should, because both formats are correct. 5 more minutes. Stay with me. Example 2 is saying, hey, sine theta minus cosine theta quantity squared. This is the same thing, related. This is the same thing as y minus x quantity squared, which means you're multiplying this times itself. Remember this? Algebra 2. Not college algebra, algebra 2. You can use the distributive property, or you can do, because it's a binomial and a binomial, you can do first, outer, inner, last. Some people like that. So first, outer, inner, last will be y squared minus xy plus x squared. So you got y squared minus 2xy plus x squared. Yours is going to go the same route. Then you got to go back and throw in your trig functions. So this was actually sine squared theta minus 2 sine theta cosine theta plus cosine squared theta. Anything sticking out? 1. See sine squared and a positive cosine squared. So you would think to yourself, okay, that clustered with this plus cosine squared is actually 1. Copy the rest. Minus 2 sine theta cosine theta. Now, this is an identity that y'all don't know yet. It's coming up. It's called a double angle. It's actually tomorrow's lesson. Two sine theta cosine theta. This is sine of 2 theta. It's called a double angle. It will be on your formula sheet. It's not something you need to have memorized. It'll be something that you're going to see pop up every now and then, and you're going to be like, oh, wait, why does that look familiar? Go to your formula sheet, find it. So this particular problem comes to 1 minus sine 2 theta. Now, the one that I had in my homework, I'm looking at it, did not involve a double angle. Mine was tan. Mine did not have a double angle substitution. It did have a substitution of one of the cup games. One of those expressions where you just shift something to the other side and then you can replace. Mine did have that. If yours ends up with double angle identity, there it is. Mine was tan. Is yours tan minus 1 squared?
Yes.
Yep. You're going to end up replacing secant squared minus, so, okay, right here. Focus your attention here. Okay. Notice, hold on one second. Notice tan squared. is secant squared minus 1. And if you replace that in there, the 1's cancel. You got a plus 1 at the end. And then, so the very first tan squared, if you replace it with secant squared minus 1, your 1's will cancel, and you're left with secant squared minus 2 tan. It ends up, in my opinion, this is where it ends up not being any cleaner. Like, I personally think this is cleaner than this, but this is where they want you to go. So right here, I replaced tan squared with this. Oh yeah, and then multiply. Yeah, I did the shortcut where you square the first term, you multiply the 2 together, and you double it, and you square the last term. So that's how I got from here to here. But then I noticed this is secant squared minus 1, and then my 1's can cancel, and then this just comes down. And that's the way they want you to go. Which is not at all, in my opinion, nicer.
7.
Yeah. 7. Oh, wait a minute. Oh, look at 7. 7's beautiful. Okay. Simplify and check using a graphing calculator. Wait, is yours like that, or how ugly?
Yeah, about the same style.
Okay. So the first problem you've got is a couple of those are squared and a couple of them are not. That's a small problem. So we got a lot going on here. I see this right here, but that's not positive and positive, so I can't do anything with that yet. You also have multiplication in the middle. This is multiplication. So we don't have to worry about common denominators. We're just multiplying straight across. Sign out. We'll be left with 1 minus cosine. So go back over here. Where's my...
Actually,